1 is 4, 200, x2, 16, 3.5, and also 200. Oops. And we want a 90, I think they said. 90. And calculate. Okay, so we got the interval. The interval contains or does not contain 0. So 90% confidence interval, I'm copying it down, 9.8803, 11.12. Does it contain 0 or it does not contain 0? Anyone? Sasha, are you with us? Does it contain 0 or not?
No. No.
No, it does not. Very good. So the upper bound, 3 decimal places. The upper bound was 9.880, and the lower I meant, and 11.12. Okay, and then interpret the interval. Choose the correct answer. The researchers are 90% confident that the difference of the means is in the interval.
A.
Of course. Very good. Excellent. What does this say about priming? Since a 90% confidence interval does not contain 0, the results suggest that priming does have an effect on scores. Since 90% confidence interval does not contain 0, the results suggest that priming does not have an effect on scores. Of course, the other two, interval contains 0. No, it does not contain 0. So remember what we, yes. Preston, you wanted to say something? Sorry.
I was going to answer the question.
Please, yes, of course.
I think it's A.
Of course. 9%, thank you, brilliant. Confidence interval does not contain 0. The results suggest, so we have to reject the null hypothesis that they are equal. The results suggest that priming does have an effect. The results are not the same. Awesome, well done. Okay. A study was done on body temperature of men and women. The results are shown in the table. Assume that the two samples are independent. Simple random sample selected from normally distributed populations because the sample is 11 and 59. 59 is okay, but 11 is small. And do not assume that the population standard deviations are equal. Okay, which would, it's about the pooled. Okay. And we are using 0.01, so alpha equals 0.01. Fine. Where is the keyword? Independent sample is selected from normally the test, okay, that men have higher mean body temperature than women. So we have to select the correct test. And mu1 is for men, mu2 is for women. Which one are we selecting?
C.
Very good. Awesome. Well done. Great job. Good. The test statistic. Oh, there is no StatCrunch there button. Okay, fine. So then I have to copy those. So 97.69, 97.28, 0.81, 0.72, and 11 and 59. Okay, perfect. So we go to stats again and tests, and this is a 2-sample T test. And I will enter 97, 0.69. Then I'll enter 0.81, and then 11, and then 97.28, and then 0.72, and 59, and we want greater than, careful, we want that, and I want to draw, you know me already, I prefer to draw. I want to see the shaded p-value. Oh no, it's 0. Oh no, of course it was an upper tail test. Yes. Okay, so the t-statistic 1.5673, and the p-value is 0.0704. Awesome. Okay, so what do we conclude? So the t-statistic, 1 point, how many, 2 decimals, so 567, so it's 57. Okay, that's the test statistic. Now we want the p-value. They want 3 decimal places, 0.070. Okay, and then conclusion. So alpha was 0.01. Alpha is 0.01 and the p-value 0.007. So what do we conclude? And I'll stop after this. Is that what you wanted to say, Preston?
Yes.
If we fail to reject, the p-value is greater than 0.01. There is not sufficient evidence to support the claim that men have higher mean body temperature than women. So from this, we only have 3 questions left, but they are all the same. So please finish up the first 2 sections of chapter 11.